All right, ABGs, arterial blood gases. I know I promised you in the lecture I'd show you a simpler way to solve these. This is an area that a lot of students get stressed out on. And really, once you take it just that little step further, knowing your CO2 is your acid, your bicarbonate, that HCO3 is your base, and what that does to the pH scale, we could really just take it one little step farther. We don't have to worry about memorizing arrows like the Rome method that the textbook teaches you. If you prefer that method, that's fine. Both will get you the exact same spot. But in our case, I feel like there's a much easier way. Let's give you an example and we'll go from there. First off, we know with our pH scale. If the pH scale is high, that's alkalosis. If it's above this 7.45, we know off the bat that it is an alkalosis. And if it's below 7.35, that's acidic. That will be acidosis. For problems with our CO2, if it is out of this 35 to 45 range, that is going to be a problem with the respiratory system. With our HCO3, our bicarbonate, that is out of range. That is a problem with our metabolic system. And so just taking it from there, let's do our first problem in our attached slides. We have a pH of 7.18, a CO2 of 38, and an HCO3 of 15. First thing we'll do is look at our pH. That pH is 7.18, which is falling well below our scale, which would mean acidosis. Next is our CO2 is 38. That's perfectly within range. That's not a problem. Then our HCO3 is 15. That is well below our range. That is metabolic acidosis. And it really is that simple. Let's do another one. The Rome method, it has you respiratory opposite, metabolic equal. You're memorizing which way arrows are turning. It doesn't need to be that hard. Let's do our second one. We have a pH of 7.60, a CO2 of 30, and an HCO3 of 22. First off, we'll look at our pH. 7.6, that's high. You know, we got alkalosis. Our CO2 is 30. That's low. HCO3 is 22. That's not the problem. So it's a HCO3 of 30. That is respiratory alkalosis. That patient is hyperventilating and they're blowing off all their carbon dioxide. Let's do one more and then we'll wrap up. I'll show you just taking it the next step and you'll have all the compensations as well. I tell you, what's our time here? We're at 3 minutes, 5 minutes. I'll have you pros at ABGs. pH of 7.28, CO2 of 38, and an HCO3 of 18. Look at our pH, 7.28. That is low. We have acidosis. Our next one's a CO2 of 38. That's normal. That's not the problem. And our HCO3 is 18. That's low. Metabolic acidosis. Now you're thinking, what if our CO2 was off right here? What if we had a CO2 of 33? Our HCO3 is 18 and our pH is still 7.28. In that case, when you have both of these off, it's looking for an answer that is compensated. So the first thing you would look for your compensated is it fully compensated or partially compensated. If your pH was within normal range, that would mean it's fully compensated. With our pH still off and out of range, that would only be partially compensated. And then from there, you're going to look at your two figures. Which one is going to be further off? You may also get clues to your patient's condition, which would clue you in of what the underlying cause is. If it's respiratory in nature and we have acidosis, it's going to be partially compensated respiratory acidosis. If it's metabolic in nature, in this case, the patient's having diarrhea, we have these figures here with all three off. It's going to be metabolic acidosis, partially compensated metabolic acidosis. But really, even just for basic ABGs, come right in, look at your pH, look at your CO2, look at your HCO3, identify which ones are off, and go from there. Anyway, if you have any more questions on these, feel free to reach out anytime. I'm happy to jump on Zoom and work as many problems with you if you'd like. Otherwise, I'll see you in class.